Okay, good morning. My name is Ciarán McManus. I'm the BIM surveyor for Mercury Engineering. I look after all surveying works on our various sites, 3D laser scanning, stakeout, single shot points. That's all taken back to our BIM department down in Newbridge for verification purposes and for redlining and as-built. So what I'd like to talk about this morning isn't so much our BIM journey as a whole or how we implement processes and techniques on site. I want to focus on one particular solution that we've developed to help us meet one of our business goals. So it's how we use our digital technologies and BIM softwares to achieve that process, and how we use it to drive the solutions that we need. So just a small bit about Mercury Engineering and our BIM department. We're a large M&E trade contractor. We officially began to implement BIM, building information modeling, in 2011, which was initially it was on the back of client requirements. However, we quickly recognized the productivity gains which could be achieved, particularly through the use of the data inherent in the model and how that can be used for prefabrication and to give a superior visibility over procurement and scheduling. So while we're in existence since 2011, we moved to a dedicated BIM hub in September of last year. Prior to that, we were based on site for each of our relevant projects. So we opened a BIM hub, which is based in our prefabrication facility in Newbridge. This acts as both a physical base and a knowledge base. All our BIM activities are centralized through this one location. And since we're co-located with our prefabrication facility, it gives us greater collaboration between both departments. It makes management of our resources easier, and it gives us greater control over the process. So the particular process I'd like to speak about is our model deviation and analysis and correction process. So essentially, before we issue an isometric to fabrication or to construction, we want to ensure that that isometric is correct and that the element that's prefabbed and sent to site will fit. So our ultimate goal is to achieve right first time construction. So any pipe, tray or piece of equipment that leaves our shop, it arrives on site and it's installed correctly with no need for rework and no need for site adjustment, which is going to affect our schedule and is going to affect costs. So BIM technologies have given us the capability to achieve this goal. A lot of projects we've been working on, the complexity of the spatial coordination issues has increased. And to give an example of this, we recently worked on a new build process plant in Groningen in the Netherlands. The plant was constructed as an extension to an existing facility. It was constructed on an existing concrete base. There was new equipment to be installed in the existing factory, and pipework and electrical services were to be run between both. We travelled over to the Netherlands. We scanned the facility. We brought that data back to the office, and the digital construction technologies were used to determine our accurate geospatial layouts to the existing facility, then to superimpose our new layout over our old, which gave us greater confidence in allowing for isometrics for prefabrication. So we've developed a process which has looked to identify any issues that may arise on site through out of alignment, from as-built or from incorrect modelling, and we've developed a virtual remedial action process. So what we do is we identify initially our area that's to be captured, to be detailed. Now that can be something as simple and straightforward as a connection detail, or it can be a large area such as a full plant or a full facility. In terms of connection, we're not only interested in the position, but we're also interested in the type and size of that connection, so as our guys can accurately model the detail that they need so as the connection fits correctly first time on site. Once our area is identified, we'll go on site, we'll capture a required field condition using appropriate survey techniques. We will then produce a deviation report as to how much the construction tolerance differs from design, or sorry, how much the construction itself differs from design, and we'll check and see is this within tolerance. If it is within tolerance and no further action is required, we proceed to issue our isometrics. They're sent to the fab shop and then on to construction. If there is an excessive deviation, then we need to remodel and we need to produce revised constructible documentation. So our field data capture technologies. Over the last year and a half or so, we've developed a strong level of knowledge in the area of laser scanning. And this method is predominantly used to capture large areas for purposes of spatial verification. We also utilize total station for survey of connection details, and we've developed an in-house bespoke solution to manage this data, which will also allow us to embed the relevant connection details and imagery that we need into the point, and to provide this to our BIM modelers in a native drafting environment, which makes it easier for them to use the data up front. They don't need to worry about searching through different files or folders for the information they require. It's right there in front of them in their modeling environment. All of our field data capture and survey techniques are supported by our own appropriate standard operating procedures, conform with our Mercury BIM survey specification, which we developed with the help of the DIT and Avril Bain with the CETA Smart Challenge. So once our field data is captured, we run a deviation analysis. A mesh is created from the model, and in this instance, as illustrated on screen, we have an external pipe rack. So we extracted the rack from the model. We created a mesh from that. We then superimposed the 3D point cloud on top of the mesh in an application called Cloud Compare, and we ran an analysis between the two to see where our deviations were. So a deviation report is produced. We'll first look at the overall deviation and check and see how our tolerances are, or how we're fitting in. We'll subsequently break down our analysis by element, and we'll conduct a detailed analysis to see what needs to change in our model. Is it a full pipe run? Is it supports? Is it connection details? What exactly do we need to change? At this point, we'll answer the main question of our process flow. Is a remodel required to produce constructible documentation? Again, if it is, we proceed with remodeling. If not, we can issue our isometrics. So if a remodel is required, we'll use the scan data that we've captured for the deviation analysis, and we'll use the scan as an appropriate background condition. This will allow our modeling teams to use the various applications, our various modeling applications such as CloudWorks, CADWorks, Navis, and Scan to BIM. This will allow the guys to model accurately within the conditions as they are on site. When that process is complete, all our constructible documentation is then issued. It's issued to the fab shop. It's issued to the guys on site. They can proceed with the fabrication and the install as required. You know, our process hopefully will achieve our goal of right first time. So, with Mercury's adherence to lean construction principles being of utmost importance, our BIM process has established a set of digital construction technologies which provide the cornerstone which supports all our best known methods. And as such, the data developed by our BIM team has become a quite important tool in offsite fabrication, procurement, logistics, manpower planning, material ordering, weld logs, and our tool and plant hire. So, thank you.